Welcome to the session on algebraic methods, partial fractions. The objectives for this session are to convert an expression with linear factors in the denominator into partial fractions. A single fraction with two distinct linear factors in the denominator can be split into two fractions. This process is called splitting into partial fractions. So, for example, 3 over x plus 7 times x minus 5 is identical to a over x plus 7 plus b over x minus 5, where a and b are constants. So notice that we have rewritten the expression on the left as the sum of partial fractions. There are two methods of finding constants a and b, either substitution or equating coefficients. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 1a first. We are required to split the expression shown on your screen into partial fractions by substitution. So let's solve this. We let the expression equal or be identical to a over x plus 3 plus b over x minus 2. We then add the fractions on the right-hand side by putting them over a common denominator as shown. Therefore, we now have that the numerator on the left-hand side is identical to the numerator on the right-hand side. If we let x equal 2, and we do this in order to get rid of the a term, we obtain 5 times 3 on the left-hand side, and a times 0, this was what we were trying to do, get rid of the a. So a times 0 plus b times 5 on the right-hand side. This gives us b equals 3. Now if we let x equal minus 3, we have 5 times minus 2 on the left-hand side, and a times minus 5 on the right, plus b times 0. And of course, this is why we put x equal to minus 3, so that we could get rid of the b and find a. And so tidying up gives us that a equals 2. So we've found the values of a and b. And we can express our fraction as 2 over x plus 3 plus 3 over x minus 2. And now for part B. We are required to split the expression shown on your screen into partial fractions by equating coefficients. So let's express this as a over x plus 3 plus b over x minus 2 as shown. And then, similar to the previous part, we express this as a single numerator over a single denominator. And again, we have a similar expression as previously. Now let's multiply out. So on the left hand side we have 5x plus 5, and on the right hand side, if we multiply and tidy up, we have ax plus bx, we've put the x's together, plus 3b minus 2a, we've put the constants together. In other words, a plus b times x plus 3b minus 2a. So equating the coefficients of x, we have 5 equals a plus b, and equating the constant terms, we have 5 equals 3b minus 2a. Here are the coefficients of x, and here are the constant terms. We're going to call these equations 1 and 2. Solving by multiplying the first equation by 3 and then subtracting the second equation gives us 10 equals 5a. And this gives us a equals 2. We can substitute a equals 2 back into equation 1 to give 5 equals 2 plus b. And rearranging this gives us that b equals 3. So a equals 2 and b equals 3. The method of partial fractions can be used for more than 2 distinct linear factors in the denominator. So for instance, in the left-hand side, as you can see, we have 3 linear factors in the denominator, and therefore we can write this as a over x minus 7 plus b over x minus 4 plus c over x plus 1, where a, b and c are constants. And these can be found by either substitution or equating coefficients. We should add here a word of caution. This method cannot be used for a repeated linear factor in the denominator. So for example, 8 over x plus 3 times x minus 2 all squared cannot be written as a over x plus 3 plus b over x minus 2 plus c over x minus 2. This is because x minus 2 is a repeated factor, and we will discuss this in a later session. Let's now take a look at an example. Split the expression shown on your screen into partial fractions by substitution. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. We can express this fraction as a over x plus b over x plus 3 plus c over x minus 2. And then express these 3 fractions as a single fraction as shown. We can now say that the numerator on the left-hand side is identical to the numerator on the right-hand side. And now let's plug in particular values of x in order to find the values of a, b and c. So letting x equals 2 gives us 2 times 3 is identical to a times 0 plus b times 0 plus c times 2 times 5. And therefore, we have that c equals 3 over 5. Similarly, letting x equal minus 3 gives us 2 times minus 2 on the left-hand side is identical to a times 0 plus b times minus 3 times minus 5 plus c times 0 to give us b equals 1 over 15. And finally, letting x equals 0 gives us 2 times 1 on the left-hand side and a times minus 2 times 3 plus b times 0 plus c times 0 on the right-hand side. And this gives us a equals minus 1 over 3. And therefore, c equals 3 over 5, b equals 1 over 15, and a equals minus 1 over 3. These can all now be plugged in to give us this expression here for our fraction. This brings us to the end of this session. If you have understood its contents, you should be able to convert an expression with linear factors in the denominator into partial fractions. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.